Hey, hey, how's everyone doing? Hope you're all doing well. Man, I am so pumped for today. For those of you who have been to another TKS talk and you're returning, that's amazing. It's been such a wild journey. If you think about it, we've done TKS talks with people from Uber, SpaceX, Tesla, Microsoft, Apple, Netflix, and today we obviously have our awesome guest speaker from Google and specifically Google Brain, which is Google's AI division. And our guest speaker will talk a little bit more about that. And for those of you who are new here, I thought it would be worth talking about why we even do TKS Talks in the first place. So, my name's Nadeem. I'm one of the founders of an organization called the Knowledge Society. And what TKS is a 10-month innovation program for students all over the world. So, it doesn't really matter where you are, but to come and we'll train you on how to be the best version of yourself and build really awesome projects using emerging technologies. So, you don't need to know anything about all these emerging technologies like AI, quantum, nanotech, gene editing, stem cells. But if you join TKS, you're going to be a part of a global community of driven, curious, like-minded people working together to solve some really important and interesting problems in the world. So that's why we do what we do. And as a part of TKS, we have this crazy mentor network. And the reason why we started TKS is because we wanted to share this network with everyone all over the world. Right now, we have people from, I think, 30 plus countries, which is insane. And I'm super excited that we are able to share a lot of the knowledge and wisdom that our guest speaker has with all of you. And really, the goal here is to inspire you to do something different. A lot of you guys are curious, you're driven, you have a lot of energy, but where do you put that energy? And my hope is from this conversation, you'll know if you're someone who's interested in research, how to get into the field and how to get hired by companies like Google and OpenAI and whatever. B, spark some sort of interest in something different, something curious to explore further. And C, an idea of how you can get started now. You don't have to wait until university. You can get started now. It's funny, Elon Musk talks about how everybody who has a phone has 99% of the same information that he has just by having access to the internet. And so we live in this time now where what historically we couldn't do 20 years ago, we can do today. We can build things. We can learn from the best in the world. And that's really why I'm excited to do things like these TKS talks. And hopefully you guys take something away from this. So super, super excited. Another thing to actually mention is just on my script here. Um, as a part of TKS, we work with organizations on something called a challenge, where we work with a company or organization on one of their top business priorities. And this year, we're working with the United Nations, not model United Nations, like the real United Nations, on solving a really important challenge that they're facing, and the X Prize. If you don't know, Elon Musk dedicated $100 million to figuring out how we can solve carbon capture, and TKS is helping them and providing recommendations to advance that mission. So it's super, super awesome. One of the things that I wanted to highlight is that you can start now. You can do some pretty incredible things now, but a lot of people are they're second guessing themselves as to what a 15, 16, 17-year-old, even younger, can do. And so before we get into our main event, I actually wanted to show you an example of someone who's currently in TKS. They're like 6 months in, but who came in not really knowing anything about anything from an emerging technology perspective, but now is working on AI, artificial intelligence technology, to detect brain tumors and cancer cells from MRI scans. And by the way, if anybody on this call is working at OpenAI, that's something that her dream is to get an internship at OpenAI. Shane, I know you know some people there, so if you're impressed, maybe we can make something happen. But that's the thing that I wanted to start off with, and then we'll get into the guest speaker. So Ashley, you're up.
Hi, I'm Ashley. I'm 16 years old and I'm from TKS Toronto, and I'm super interested in using artificial intelligence in the medical field. More specifically, my projects have been using computer vision, which is when we get a computer to interpret images like a human would. Some of my more recent projects have been using convolutional neural networks, which is a type of computer vision model, to detect pneumonia and chest x-ray scans. And this is so crucial because pneumonia is actually the leading cause of child mortality for children under the ages of 5 in developing countries. And if we're able to quickly and accurately diagnose pneumonia in chest x-rays, we can save the lives of many children around the world. I've also been using these networks to detect different types of brain tumors and to differentiate between MRI scans that have no tumor and scans that do have a tumor. And I've been progressing this furthermore by taking in the tumor scans and using image segmentation and other imaging techniques to pinpoint the exact location of the tumor on the scan. I've also been super fortunate to have the opportunity to research connectomics, which is mapping the neuron activities in our brain and all the actions and the synapses and stuff that they do in our heads. And if we're able to map the whole human connectome, we'll actually be able to solve the root causes of many neurological disorders, such as epilepsy. And if we know these root causes, we'll be able to develop pharmaceutical drugs and surgical techniques to eliminate these neurological disorders. Today, I will be showing you my neural network, which can differentiate between MRI scans that have a brain tumor and MRI scans that don't have a brain tumor. I hope you enjoy. All right, let's take a look at our neural network. So for this project, I've used a computer vision model called a convolutional neural network, which takes in an input image, performs a bunch of mathematical calculations and imaging techniques, and then it will give us an output as to what the image is. In our case, we are differentiating between MRI scans that have a meningioma tumor and MRI scans that have no tumors, just a healthy brain scan. But how does the computer identify the different images? Well, I've given all the meningioma tumor scans a label of 0, and I've given all the no tumor MRI scans a label of 1. So the computer will take in an input image of a scan, just perform its calculations, and then it will output a 0 or a 1, whichever correlates to our input image. So over here, I've just outputted what a scan with a meningioma tumor looks like. And I've also outputted a scan without any brain tumor, just healthy brain. So I'm sure many of you like to play sports, and often before you play a game, you got to go to practice, so you can perform your best when you go to your game. Well, that's what we do with our neural network. So I've built our neural network here, and then I've trained it because I want to prepare our neural network to be the best when it receives images it's never seen before. So I just trained my neural network here, and then I also want to test our neural network to see how well it can perform on data it's never seen before. And I did that. I pre-ran this because if I didn't, my computer would probably blow up. But when I ran it, we got an accuracy of 98%, which is really good. But now we can even further test our neural network by actually inputting an image it's never seen before. And for this example, I inputted a meningioma tumor scan, and I ran this, and it gave us a 0. And if you remember earlier, I told you guys that we gave scans with a meningioma tumor a label of 0, which means that our model predicted this scan correctly. Do you know what is absolutely insane? Brain tumors are the #1 cancer killers for children and adults under the ages of 40. And this is typically because brain tumor diagnosis can be a lengthy process. And when someone is showing symptoms of a brain tumor, we want to diagnose them as fast as possible so that we can give them the right treatment. By using artificial intelligence, we can detect and diagnose brain tumors really quick and at a high accuracy rate. And we can also use this technology in developing countries that might not have the best access to medical care. I hope you guys enjoyed my demo, and I hope you've learned something cool. And if there's one thing I want you to take away from this, is that you can make an impact at any age with the right skills and the right mindset. At TKS, I've been able to explore and pursue my passions in artificial intelligence, build really cool, meaningful projects, and learn how I can use AI to make meaningful impacts in this world. Now, back to the main event. I hope you guys enjoy this talk because it's going to be super cool, and I'll see you guys later.
So the main thing that I wanted you guys to take away from Ashley's talk is if she can do it, you can absolutely do it too. She came into TKS without knowing anything about emerging technologies or how to code. And now she's building these things in such a short period of time. So if this is something that you are interested in, TKS applications are open right now until April 5th. And after the session, we're also going to be hosting an information session if you want to know more from a student who's actually gone through TKS. So stick around after the session for that. Now I'm super excited. We're on to our main event. You can participate, and this can be interactive if you use something called Slido. So if you see the bar here, Slido is an app that you can go to, a website where you can ask your questions, and then the top questions that are upvoted, I'll ask to our presenter. So I have some good news and some bad news. The bad news is our original presenter, Pierre, told us very recently that he wasn't feeling well and he couldn't come do the talk. So we wish him a speedy recovery. The good news is we got someone else just as awesome from Google Brain. His name is Shane Gu. He's in Japan right now. It's 3 a.m. and this guy is up delivering this amazing talk for all you guys from around the world because he wanted to make sure that you still got this level of exposure. Shane is an AI celebrity in Silicon Valley. Okay, he's met Mark Zuckerberg, Elon Musk, and maybe if we're nice in the chat, he'll talk about these stories if you guys are interested in how these people are thinking about using artificial intelligence. But I'm going to introduce him. So Shane Gu is a senior researcher at Google Brain with research interests centering around deep learning and robotics and universal physics. He has a PhD in machine learning from the University of Cambridge in the UK and the Max Planck Institute in Germany. He's worked on some pretty cool people like Geoffrey Hinton, who is considered the godfather of AI, so like pretty much the person who's inspired this whole movement. And I mentioned he's even personally met Mark Zuckerberg and Elon. So his work has won tons of awards with different conferences and different people. So he's won awards with the Conference of Robot Learning, Google's Research Award, and has even been featured by MIT and MIT's Tech Review. He's a proud Japanese-born Japan-born Chinese Canadian. He's trilingual and has lived in places like Japan, China, Canada, the US, the UK, and Germany. So big thanks for joining us today, and I think you guys are going to learn a lot. So Shane, let us kick it off.
Okay, thank you so much, Nadim, and thank you so much, Ashley, for great presentation demo. It's really one of the kind of most exciting application field these days. And say Jeff Hinton, since probably 7-8 years ago, he's been saying that radiology is really one of the major area that machine learning is going to change forever for sure, for really kind of the benefit of kind of the whole humanity. And I do also have a bunch of personal friends and colleagues at Google who are very actively exploring this area. So very impressive. Congrats on those kind of work, and look forward to kind of seeing more those kind of work from you, Ashley. All right, so today I'm going to talk about my research, kind of mainly talk about very high level of like what deep reinforcement learning is, robotics is to me, and how they relate to our pursuit for general intelligence. So a bit of personal journey that I think Nadim already kind of mentioned most of it. All right. So yeah, I did elementary school in Japan, middle school in Shanghai, high school in Vancouver, and undergrad in Toronto, PhD in UK, Germany, went to a few places. Yeah, so during like a interview after I got offer from OpenAI, I was very fortunate that on the visit day, Elon was there. So the people at OpenAI kindly allowed me to have kind of some one-on-one chat with him, and he kind of asked me why don't I join OpenAI, and those kind of questions that I can probably share later. Yeah, I write, read, and speak in 3 languages. Some hobbies: swimming, tennis, and if I share like a bit of kind of fun story, I play tennis on Mars. So if you remember the news from last summer, the whole Bay Area was basically burning for like a month and a half. And during the day where it basically becomes Mars, I grabbed some friends and we played tennis. It was actually this one day that weather condition was good. And the second thing is I did backpacking in thunderstorm. Very naive. I definitely don't recommend it. In Yosemite, it's a famous kind of mountain range in California. Very beautiful, if it's not during thunderstorm. So to summarize my research journey, I basically have two goals. First is I try to answer fundamental research questions in deep learning. It seems obvious, but typically the question I ask is, does this idea make impact for many exciting applications? I think that's what it means to be fundamental. That's what it means to be kind of impactful. So I'm kind of interested in many kind of topics. I've been in like a few labs. So Jeff Hinton's Toronto lab specializing in deep learning. In Cambridge in UK, they're super good with Bayesian machine learning. And in Germany, they're really into non-parametric, like kernel-based method, as well as most recently causality. A lot of very exciting areas in machine learning. The second thing is really how can we achieve artificial general intelligence? Many people talk about it. Many people say it's a hype. Many people say it's a futile path. Why do we do it? I'm still very excited because really getting a sense of intelligence is, I think, one of the most rewarding things as you do machine learning research. So I'll talk about what are some kind of interesting questions here. But here's really like, how can you make some form of intelligence in 5 or 10 years? Is the time span I consider. All right, so brief background in machine learning. I think Ashley did a great job on this nice example from supervised learning. So there are a few types of machine learning. The first type is supervised learning, which is you learn to predict outputs from inputs given many examples of input-output pairs. So you recognize objects and images, you translate from one language to the other language, you look at these medical images, nice, that have the same example, and then you find if it's you find a diagnosis, and say you translate from speech signals to text. So the way I see supervised learning is actually a form of translation. It's translating from one form of information to another form of information. That's kind of how I see supervised learning. And I can probably describe or can explain later, but I see this as a common characteristic of intelligence, but it's really not the intelligence itself. But it's a very useful tool. Like humans, when we look at things, we can easily abstract, we can easily figure out high-level concept of what this means. We're doing all sorts of supervised learning, abstractions, representation learning, representation transformation, whatever the words I use, like day to day. So it's super exciting, kind of core technology of the field. Then there's the reinforcement learning. So reinforcement learning is you learn to predict outputs given inputs repeatedly, like this interactive manner, to maximize long-term rewards. So unlike supervised learning, where you're given many examples of outputs to give given inputs, you basically need to kind of figure out the optimal outputs through interactions and trials. So for example, like in robotics, when you want to teach a robot to assemble pieces together, you let the robot try, and if you succeed, you give it a reward. If it fails, you penalize it. And just like kind of how you train, maybe some of you have pets, they'll kind of gradually learn to reinforce the behaviors that maximize the reward. And that's how you can kind of find the optimal things for the problem. So I see this as optimization. And I closely associate intelligence definitions with optimization, and really feel if you really want to directly get at this notion of intelligence, you have to do the reinforcement learning. As OpenAI, DeepMind, pretty much like a lot of it is kind of focused on, at least initially. And they figure out there are a lot of supervised learning they can do. So they're making so many impacts in many areas. Okay, so let me talk about like one example of what I mean by fundamental research. So it gets a bit messy here, but I try to kind of keep it simple. So you see this neural network is something that takes inputs and have a bunch of neurons and these outputs, and basically each neuron is doing a bunch of computations. And often the neuron have this sort of activation function that does some kind of nonlinear transformation, and you can compose a complex function. But typically neural network only use smooth functions, because with smooth function, as you see, for example, if you want to make the y value to be 1, then if it's on smooth function, you know, like everywhere on the x, you know exactly how the error changes. So here is a bit worse than here. Here's getting better. And in the middle is getting better, better, better. You get this kind of continuous signal. But in discrete function like step function, then you get it wrong, 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 and suddenly you get it right. So the error signal is like 0, 1. It's very hard to learn. Kind of like for humans as well. You know, if you're only given 0, 1 reward versus, oh, you're like 0.9 good, you're like 0.99 good, then you know, like which one's easier. So, and also, why do we care about this kind of discrete functions? Because computers, they use this kind of like binary or discrete values like 0, 1, rather than some kind of floating like continuous number. It's really, you can, if you do that, you can really preserve information almost perfectly. You can even information sort like guarantee that with some like percentage, the information is fully preserved by doing a lot of error correction coding and stuff. And also, this is kind of how many people see brain work as well. So if you know this kind of how neurons excitation thresholds work, they often is like this threshold, and after that, it basically fires. And you can kind of see this as approximately more like a discrete signal than continuous signal. But you know, who knows how brain works? So I put a small question mark here. Yeah. So this is a fundamental question. And I published 2 papers on this. One's called New Prop, another was Gamma Softmax, with this great young person who kind of joined Google at the time, like Eric. And the nice thing is, once you work on fundamental research papers, it typically can, you know, it typically will have many applications. Sure, like there are a lot of architecture occupation paper that's also very impactful, or like much more impactful in terms of citation, but this is nice because it's kind of proposing something new mathematically, and it actually led to very tangible applications. So for example, there's very nice research. In fact, this is from well, actually, no, both of them are from OpenAI, technically, yeah. So one is this kind of emergent communication, where so you have this kind of different points that's trying to achieve some goal. And what you kind of give is that you kind of give, like, they can only communicate through passing a discrete message. You know, it's kind of like how humans do, right? Like when we, you know, we can use like a text to communicate between each other. And here it kind of says that if you make this kind of bottleneck and make a multitask, then something that really resembles like language can almost emerge. So super fan of this research, and actually the first author, I think, of this one is currently, yeah, so Igor is currently working at the Google Brain. He's a fantastic colleague who's kind of inspired a lot of researchers. And it's also used by this most recent paper from OpenAI called DAO-E. You guys should really check out this website, because this was definitely one of the things that surprised me most in the past 5 years or so. And so this is generating images from texts, but the really cool thing is how abstractly it really mastered concept. So if, for example, generate the chair in the shape of avocado, which really isn't there too much on the internet, and it really kind of grasps what it means to be avocado to like humans. And this one above is kind of more abstract, you know, it's kind of like illustration, a baby and daikon, like reddish, and walking a dog, and it's basically generating like something that, you know, I can only kind of imagine human designers made. So, and the nice thing about this is you can change, for example, baby daikon to something else, and you can still generate a lot of realistic examples. So you guys should check it out. But what for example, this discrete function research was able to do, it was to basically kind of have a like part of it. So in their big model, there's a part that use a general models latent codes with discretized codes, and our method basically gonna show how you can train such models. So it's really kind of good to see how some of the fundamental research can be translated to really cool applications like down years. So this gamma softmax I think was like 3-4 years ago. This DAO was just like last year. So it's nice. Okay. All right. Then I'll talk about another example of this one's more fundamental research plus AGI. So it's talking about intelligence definition. So why do we care about intelligence definition? If that is kind of really get to why you need to know mathematics and computer science. Basically, without precise definitions, you cannot write down the mathematical formula. Without the mathematical formula, you cannot program to optimize it. But if you can write it down as a mathematical formula, that means you can program to optimize it. So that's kind of my way of approaching pretty much any problem. So we should really care about precise numerical definition for intelligence. And there's been like many arguments for intelligence. In fact, this collection from a survey paper, this Shane Legg is one of the 3 co-founders of DeepMind. So this intelligence definition, which was also his thesis, that he tried to define numerically, was one of the 3 pillars of stories that allowed them to establish DeepMind that got acquired by Google for like $600 million, $700 million. I put a few examples here. You guys can take a look, but it has like many of shared traits like solve problems, adapt to new situations, whole thing. Okay, so to simplify the talk, I'll give a very coarse formula for intelligence. This is largely inspired by Shane Legg and Marcus Hatters and Francois Chollet's papers. But I just write intelligence as proportional to skill generalization divided by prior past experience. So what does it mean? Skill generalization, I mean how well the agent can solve new tasks after learning. And so basically kind of how well, some performance metric of the agent respect to some pool of tasks. But you have to normalize it by how much does the agent already know before learning. So this we call prior. And the experience, which is how much data the agent used during learning. And this actually directly connects to sample efficiency research that I'm going to talk next. So, intuitively, sample efficiency measures how many trials does it take for agent to learn a task. And, if you probably watch over, generally probably if the agent required a few trials, so putting a block in the thing, or I think Nadeem mentioned the stove test. So you touch the stove, it hurts. How many times do you touch the stove before you kind of know that's a bad thing to do, for example? But yeah, fewer trials required should be more intelligence. And sample efficiency is really how can we improve the sample efficiency of those R algorithms. So I wrote one of the first papers on this area and pretty much kind of showed this sort of deep reinforcement algorithms that many people only show they can work in games, so simulated environments, can actually teach real skill on real robots. So here, on all those 3 examples, all the learning is done on the real robots. So this one is using, robot arm to open a door with 2 arms. It can, it only takes 2.5 hours to learn how to open a door. And with this, so one in the middle, it's pickup. It requires a lot of data, but improve performance a lot from 70% to 96%. And third thing is teaching this 4-leg robot to walk. And all the learning was done on real hardware, and it was able to learn in 2 hours. So yeah, basically improving sample efficiency, one, you can kind of guarantee that you're improving the intelligence of the R algorithm, because, how do you know if it's just because it's using more data or because the algorithm is smarter? And second, if you can make the algorithm sample efficient, it'll be useful for many real-world problems. So this is definitely one of the kind of core area many researchers work on. Okay, and then I'll talk about another side, which is about tasks. So when I talk about skill generalization, one of the natural questions, what are the tasks that we should kind of measure? This has been quite a big problem, both for those papers I reference, but I can kind of sort of give where I come from. So take a look at this orangutan. And so if you kind of contrast kind of thing animals, humans, we can do in continuous control, using our hands, using our mouths, like to manipulate the things around the world. And if you contrast that with games, my feeling is in games, each of the worlds is designed very differently, pretty much arbitrarily by designer. So the only thing you can sort of share across games is just very notable vision features for continuity and something like very high level strategy about how you're going to formulate the plan or how do you do search. But in continuous control, okay, so here the orangutan made a hammock and then it got in, but so basically orangutan found this was too small, so of course it's going to untie the curtain from the cage and it's going to tie again to another place where obviously you can make a larger hammock and bring it. But if I can see I can train an agent that can do what this orangutan can do, that to me is much stronger existence proof of intelligence that can grow infinitely in terms of its skill sets. And it can because continuous control has an infinite thing you can do, but it's very finite regularity. Everything you do has to satisfy laws of physics. And I think, you guys are high school, so you kind of know that laws of physics are actually very simple, right? There aren't that many equations in laws of physics. So so like, animals can learn it, we can learn it, obviously the AI can learn it, given enough examples. So I found robotics to be a really great test bed for general intelligence, and this is kind of why I work in robotics. Okay, let's ask like another question about tasks. So taking a step further, within robotics tasks, which tasks are harder for typical algorithm? This is actually a very hard question. So 2-3 years ago when I was interviewing with Facebook, someone asked me this question and then I basically gave I don't know answer. And then the professor who asked me, she also agrees that, we don't know. And that was good enough for the interview. So it's a hard question that many people don't know. But to give an intuition, so DeepMind was able to show this Asian doing very cool locomotion and parkour like 4 years ago. And this year, OpenAI just released a paper about this hand with gripper doing some stacking. So at least to me, this is kind of counterintuitive that if you look at some degree of freedom, it seems like manipulator, this manipulation task should be much easier. Definitely like is one of the simplest tasks that I think we can associate with, given that we have such flexible, dexterous hands. So why is this manipulation of just square blocks harder than controlling, I don't know, it's like 20, 30 degree freedom humanoid to run across rich environments? So my intuition is about connectivity between the actions and the future states. So what I see is if your actions you do can affect the states that's relevant for the task better or easier, then the task is easier. So basically intuition is, you just do some random action, you kind of see that random part of state changes. In locomotion, because everything is one body, so you move your arms, and because your center of mass is attached to it, so it does affect it to some degree. In manipulation, you have to, as you move your arm, you have to touch the object to affect the state of the objects. So that was sort of like intuition of how we come up with this paper, and we submitted. We're working on this toward archive and waiting for the review. Okay, so as I kind of finish talking about the research, I'll share like a parting thoughts about this humbleness. It had nothing to do with like almost research, but I just want to kind of share this thoughts. So the important value of scientific career is humbleness, is what I see. Because as a researcher, given sufficient new evidence, you're always open to change your views. This is what I think define a good researcher. And reading books also teaches humbleness. So especially like reading history books that cover long time spans and diverse geographic areas, and psychology statistics books covering human fallacies and attributes. Those books really can tell you about how universal human is and how also sometimes predictable humans are. And then it can really make us kind of appreciate our specialness as well as make us very humble that we can easily make mistakes. We can easily be fooled to repeat the same mistakes over and over and over and over. And why humbleness is especially needed these days is because of information overload. So internet SNS allows anyone to spread opinions as facts, and technology is really not sufficient. Like fundamentally, it's really the question like who can label which are facts? Fox News, other places. We really don't know who can label facts. But if everyone stays humble, respect each other, evidences, keep thinking important matters, I think the world can understand each other better and collaborate better to solve necessary problems like climate change, basic things that we should just kind of tackle together as a society. Okay, so thank you very much. I'm kind of always open for kind of question stuff. So, people kind of email me sometimes. I try my best to kind of answer. You can also follow me on Twitter, but really kind of exciting about this initiative that Nadim and his collaborators are doing, and hearing stories from people like Ashley. I do also personally know like 2 or 3 like papers that I was very impressed that's written by high school students. So again, it's their message. You can start at any age. And yeah, super excited that they're organizing this kind of initiative. Like everything, like all the code base, like many of the code base are open source. Educational materials are very abundant. Many people writing blogs, making YouTubes. It's really one of the best time for those who are kind of motivated because they can really kind of start and they don't need to be physically at the university to learn. So yeah, thanks for invite and look forward to the Q&A and answer kind of more questions.
Shane, this was awesome. And one of the things that I want people on this call to understand is AI. A lot of smart people are saying that AI is really the next frontier in terms of human evolution and to be able to solve problems, right? AI can solve problems and improve productivity and say robotics as an example. As what Ashley talked about, it can help us diagnose medical images and disease a lot better. And it can help us solve problems. The idea is that it can help us solve problems that it would be really, really difficult to solve. A lot of people are thinking about how we can use artificial intelligence to create drugs for cancer, as an example. But I want everybody to understand here is that it's not magic. It's people like Shane who are really putting in the effort to discover the underlying infrastructure and the architecture and the intuition behind this technology. And so, again, if you are really interested in research, or if you're interested in having a lot of impact, this type of work is really, really important as the foundation for all of this awesome stuff to happen. So, Shane, one of the questions that I wanted to ask you is, you've always been really interested in math, and I remember you studied engineering science in your undergrad, but you and I both started or had some sort of journey in entrepreneurship as well, and starting a company. When did you realize, and why did you realize you wanted to go into research?
Yeah, that's a great question. So in fact, so Nadif and I, we basically kind of same age, and then during our like second year undergrad, we both just like entrepreneurship incubator. And to me, that was actually like one of the point that I found myself, at least for me, I'm most interested in kind of working on kind of problems where if I try kind of hard enough, there's a clear yes or no. So in a lot of kind of science, you try to kind of make really kind of concrete decision, and then it seems like that way of kind of thinking kind of fit me the most. While in business, I think takes more kind of human convincing and really kind of be comfortable with uncertainty as you make kind of big decisions. But one of the things was really kind of what I got from Next 36. So in Next 36, I was introduced to this person called Ken Nickerson, and he was really kind of long time software engineer at Microsoft and very smart person. Even to this days, I think he still buys his own kind of hardware boards and then does very hands-on engineering. He's like a really true engineer, but he's basically like a mentor to many of the business and startups. Super smart guy. And we had a few chats, and he recommended me to take this class from a professor called Steve Mann in Toronto. So he's a super unique character. I think if you search his name and find his picture, like super unique, you'll never forget about him and thing. But he was a really fun person. Like he had his lab, and then where was kind of PhD students kind of come, and it's basically like a workshop. He even sometimes bring his, I think, 4 or 5-year-old daughter to the lab as well. Very interactive. He's always there, and we kind of talk about ideas, questions. He's someone who's really committed to education and research. And the nice thing was during that, I was able to work on a paper with, I think, 3 other undergrads and then 1 master and 1 PhD that got into a demo at this conference called SIGGRAPH. So SIGGRAPH is one of the biggest conference in computer graphics. And I was able to attend like in my 3rd year. And there I was at the booth and kind of demoing stuff. And like everyone come to the booth, including like very old people, like I don't know, like at that time, like 40-year-old, like 50-year-olds. But they really like asked me, like I was only like I think 20, 21, I don't know. And they kind of asked me like, okay, how do you do this? How do you do this? Like, and I found like to be interesting because that hardware, which we know like as undergrads and like master, like we know like it's not that special, it's not that hard, but to many people out there, this was kind of one of the first demos they kind of saw, and they got super excited. They asked a lot of questions. So the thing really inspired me to research was that idea of international community, like everyone in the world who kind of attends this kind of conference is really looking at the next frontier. They know what has been done, what's really noble. Everyone's exploring a noble thing. And that community and this like pursuit for like really kind of nobleness, something that people haven't done before, people haven't shown before. That was something very exciting. And if I kind of see another example is when I worked with Jeff Hinton in my 4th year, that was a year it was busy for Jeff Hinton. He made a company that was acquired by Google. He was pretty much acquired by Google in the middle, and he also worked on this Coursera course, which I highly recommend students check out. It really doesn't require more than high school math, I think, to learn beginning. Yeah, so he was kind of busy, but he always kind of guaranteed time to meet with me, like every 1 or 2 weeks. But even using the time, so for example, like after the students are gone, like even like 9 p.m. or like 8 p.m. or 9 p.m., like he was like the last person in the office. And I think, I don't know I forgot the exact age, but probably like 60-year-old. But he's like super excited, like doing research, and like I attended his weekly meeting. He always had like very fun idea, excited idea to share with students. Having something that you can be so excited about until that age and probably pretty much forever is really one of the kind of constant, because you're always exploring for novelty, you're always kind of building your knowledge, and that I think those few things inspire me to go into research.
That's awesome. And I know a lot of young people are thinking this as well. Like we talk about research as almost this nebulous term, but what does a day in the life of a researcher or someone like you look like? I know it's probably different, but like what do you actually do?
Yeah, so I'm definitely on the blessed side. So like yeah, currently it's really good to be a research scientist at machine learning. I think at pretty much all the places, many other places, because the technology is going to be so fundamentally like useful for many things. So company allow you pretty much have full freedom to do whatever you want. So for example, Pierre is my manager, but then I basically just did my own research. Yeah, I guess I still haven't written paper with Pierre. I really want to do that, but I basically just find my own topics, find my own like research to do, and Google gives like a lot of flexibility. So, for example, like 2 years ago, I was spending 1 day a week working from Stanford, visiting a professor, interacting with students there. Right now, I'm supervising some student in the University of Tokyo on research, and we wrote a few papers. But in terms of like kind of day-to-day time, it's really kind of up to you. You can spend like the whole, I don't know if it's encouraging, but you can spend like whole week just reading paper. You're kind of like, because that does inspire your next research, and Google knows to value that. So basically, it doesn't do any micromanagement or basically any management. Yeah, at least like I'm currently enjoying that status for the time being. And I can basically decide, okay, this is a day I want to code, this is a day I want to write, this is a day I want to read. I can decide how I'm going to allocate my time. And as long as it sort of fits in this like general machine learning, which can pretty much cover
Yeah.
everything,
So the good thing for everyone,
it's good. Yeah.
yeah, I was gonna say the good thing for everyone listening is that there's a lot of flexibility when it comes to research because it is a sandbox where you need to discover and think of new ideas. And if there's a lot of process and structure, it's very difficult to be able to come up with these new ideas. And for everybody, again, on the call, historically, you might have been thinking that research only happens in academia, like in a university. But that's shifting a lot nowadays. A lot of research is actually happening within companies like Google, like OpenAI, DeepMind. And there's also in a lot of different fields, not just artificial intelligence. So if you think about quantum computing, if you guys have heard of that term, pretty much every quantum computing company is a research company because we haven't cracked it yet, right? Any new gene editing company that's coming out that has to do with CRISPR, which you might have heard of, is a research company. And so, as Shane mentioned, there's a lot of uh, value now being able to do research at companies because there's a lot of flexibility and there's a lot of resources to just explore and figure out whatever you want. So for those of you who are like, I don't want to go down that PhD route necessarily, or want to work in a university lab, there are other ways to potentially do it. But
Yeah, yeah, this is actually kind of great point. So, for example, like it's definitely not the only problem with Japan, but in Japan, especially, like they have a lot of bias for the PhDs and research, because there aren't that many companies that can appreciate it. But in the US, UK, like Europe, there are a decent number of kind of companies that kind of know the value of some of the research, so we kind of really actively hire and then give flexibility that's suited for researchers. Yeah.
so Shane, you've collaborated with some of the top uh, AI researchers in the world, right? People at OpenAI,
Yeah.
DeepMind,
Yeah.
at a bunch of different companies. But it also feels like that there should be an aspect of competitiveness, right? Like Google wants to make their own research so that they can, apply some of their technologies in some of their products. What is the nature of collaboration versus competition in research? Because if you were to work at another company, not in research, you probably wouldn't be like Apple is not probably collaborating as much with Microsoft on, you know, on some of these things. So what are your thoughts on that?
So it depends on the company culture. It depends on a few factors. So in my view, the machine learning is one of the kind of rare field that's, it's a general technique. It's a very fundamental technique. It's almost like mathematics or programming. It's a very fundamental technique. So any kind of breakthrough, it's gonna lead to new inspiration. So for people to kind of actively share what they discovered is actually gonna benefit their own application pretty well because everything we do is kind of fundamental. But it definitely does depend on the company culture. So I guess I shouldn't go against too much, but like some company definitely are like less open to like research or contributing to research. If you look at publications by companies, I think that shows crystal clear like what their company's attitude is. Google is very supportive of open research. So during my 4-year PhD, I spent 3 years of the PhD working part-time at Google. And everything I did there, I could use my own like PhD thesis, publication, everything. Like they never kind of rejected, and they even kind of encouraged me to like, if I like a few those kind of author, that's also fine with it. Um, I really kind of wish that, especially the companies who are making the most profits, who are the most valuable, who are making the most profits, can contribute back to basic research. Because therefore, different some companies that it's only going to use its own money to hire talents, to absorb the talents, and make sure everything they produce is only going to benefit the company. All the information just never leave the company. That to me is really it's not ideal. And company like Google are very supportive, and yeah, at
And
least
that's
they're
something,
different, and it has different obligations, right? It has different responsibility towards stakeholders, but it does try
and
its best to bring diversity and contribute back to the community. Yeah.
And I think that's something that Elon Musk has been doing a really good job at, is publishing and being very open about their research, making things open source, contributing back to the community. And so it's good to see that organizations like Google and some of these other people are doing that as well. Um, Now, if someone wanted to get a job at Google Brain, at one of these research institutions, Microsoft, whatever, what would you say that they look for that these young people can start building now? Knowledge, skills, mindsets, networks.
Yeah. So I have a few kind of criteria. So I think the two main thing I look at, and then I think probably also other people look at in research is one is this kind of fundamental mathematics programming skill. I think you need those, and you should definitely take a resource. Some people say, okay, I'm not good with math, but math is basically like a language. Have you spent as much time learning a language as for mathematics? So definitely encouraged to master those two things very well. Okay. And sorry, yeah, I was just kind of reading some message. And the second thing is really excitement. I think this is what I kind of value much more than this kind of fundamental skills, because there are many people who knows maths and programming. But the second thing is really kind of excitement. Excitement to do research and deliver research. This is really kind of hard to evaluate. It's really this kind of motivation. Like, are you really driven for this idea? Like, are you really driven to make it work? So, for example, for me, initially, I was definitely kind of excited about this kind of fundamental research questions. That kind of appealed to me much more than, like, say, tuning the architectures. So it was driving for me. But also, I had a lot of drive to close because, for example, I cannot really understand students who don't try to rush to finish the paper, because only after you finish that paper, you can work on the next research idea. Like, as a researcher, I think you're always excited. You always have the next question you want to ask. And to me, that's actually a strong motivation to close, to finish the current research project and kind of move on. So this kind of intrinsic motivation, closure, and also kind of bar for impact as well. Like, do you just care about publishing any paper, or do you care about publishing something that can change kind of how people in the field think? Like, is this just something that very few appreciate and then won't not translate too much to the real world impact? Or this is something that, it's going to be a key thing that people can kind of develop, or kind of key topic that we kind of follow. So really kind of having a sense for the impact of the research. So like having, I think, that good of taste is good. And this sort of really hunger and motivation to do it and close. And yeah, if I say like some of the thing is, so like I mentor a bunch of students, but something that really kind of works well for me is some students who always have kind of a question to ask. So there are a few junior students who are just really impressive, and there's something that really distinguished them was they're always curious. Like, they always ask me like very interesting kind of questions, very fundamental questions about topic. Yeah.
So Shane, this is a really good segue into the last question that I have, and then we're going to wrap it up. And thank you so much for being here. But the last question that I have for you is, if you were to give advice to a 16-year-old today who maybe doesn't even like they haven't read a research paper, but they're really interested in this stuff. They have big ideas. They want to make a meaningful impact as early as possible. What would you tell them to do now?
Yeah. So there's almost too much things we can do. So I'm kind of figuring out what to
That's a
say.
good problem to have. A lot of these, yeah.
Yeah, yeah, I'll just say it. So first of all, like there are a lot of blog posts that's written for, general audience, people with kind of minimal kind of background needed to understand. So like, and some of those are written by top researchers as well. So find the kind of interesting blogs, YouTube videos, find some topics that interest you the most and start kind of reading. And as you kind of read, you kind of figure out, okay, I need to know about this, I need to know about this. There are few online resources that even kind of teach you kind of what kind of concepts learning sequence to do. So watch like this kind of educational materials and that. But okay, so this is one. And I think another thing is, for example, like Ashley, she was very interested in OpenAI. What you can kind of find is like who do you want to work with, for example, OpenAI, for why, and then what are the kind of paths to reach that person. So, you can definitely obviously email the person, and actually highly encourage you to do that. I think the first thing you do is if you find it really kind of exciting, and if you do have some specific kind of suggestions, for example, you want to help on this part of the project, or you want to explore this bit, OpenAI tried a very nice initiative before that. They basically open source their ideas, research ideas, and basically say, okay, those are the ideas we want people to work on. If you did some results, send me the results, and then if the results are good, we'll give you an internship and stuff. I don't know if they still have that right now, but if you have that, definitely like actively reach out, right? Like you'll be kind of surprised how how much of the kind of return you can get back reply. But if you cannot get the direct reply, you can also kind of find a path. So if you know the kind of person, if you know general topic, then you can find who are people around you, right? So maybe like even maybe some graduates from high school, some people in your local university, some professor in your local university, and you can reach out to them and then kind of gradually kind of follow up to kind of reach the path. But something I definitely encourage is don't be closed mind to see that the only information, the only kind of opportunities you can sort of find yourself online are the ones available. Definitely like ask people around, and you'll be kind of surprised how much kind of opportunities out there, and how much of this kind of mentoring kind of some people kind of willing to do for very kind of motivated students out there. Definitely does rely on like a lot of self-action. You kind of give some
Yeah,
high-level direction and then you have to kind of deliver. But yeah.
that's awesome. Well, thank you so much, Shane. Everybody on the call, keep in mind it's almost 4 a.m. I think for Shane, and he stepped in, wanting to deliver a lot of value to you guys. So hopefully you guys appreciate it. Again, thanks, Shane. Thanks so much.
Oh,
Signing off for
oh
you.
yeah. Oh yeah. One last thing is like you'll be surprised how pretty much like all the top professors I know are using Twitter these days, and some are very highly engaged. So just tweet, reply on the tweet. You're surprised how many of them may like reply like your things.
Great
Yeah.
tactical tip. All
Yeah.
right. Thanks, Shane. And so
Okay.
for everybody on this call, the most important note here is if you want to play a part in fields like AI or emerging technologies, or if you want to have a lot of impact, if you want to accelerate your career and your trajectory, you have to start now. And just by going through current schools and current systems, it's not built to optimize and maximize your potential, right? Everybody else is doing it. And so you have to do more. And so, as Shane mentioned, if you want to do more, like go to Coursera and do, Andrew Ng or Jeff Hinton's course. Go on YouTube channels, learn some stuff, read a research paper, and it's going to be hard, but just go on Wikipedia and look up all of these terms that you don't understand. And so you can definitely do this by yourself, and you can start now. And if you want a more structured place and a more structured environment, where you can do this with a bunch of like-minded people from around the world, then TKS is the place for you. So again, if this is something that you're interested in, I highly encourage that you apply. Again, 10-month innovation program where you're going to learn about all of these emerging technologies, being encouraged to build things now and being put in environments where you have access to mentors, people, collaborators, resources to really accelerate your trajectory and push things forward. We're hosting an information session right now. It'll be very quick, like 20 minutes long, where we can answer some questions around TKS. You'll hear Isabella, who's a TKS student's story. A lot of you guys have stuck around for that. So for those of you who have already attended an info session, it's going to be the same. But for those of you who are interested in learning more about TKS and you want to get some questions answered, feel free to stick around. And for everybody else, thanks for tuning in on a Saturday, and good luck, and see you next time. All right, Izzy.
What's
How
up?
you doing?
I'm doing good. How are you?
Good.
Should I get the slides going?
Yeah, let's get the slides going. I know there's Zoom fatigue probably going on right now, so we don't want to keep everyone on here for, longer than they need to be on here. But yeah, let's go through your experience, introduce yourself. We'll talk about TKS. I'll kind of walk through the first, couple slides. And then we'll just get into Izzy's journey. And then after that, for those of you who have questions, feel free to ask questions in the chat, and we'll be able to answer them for you. Cool. So I just want to articulate the why behind TKS. Naveed and I, who's my brother, started TKS after working in Silicon Valley with some of the top CEOs from around the world. And we realized that there's not enough smart people in the world working on hard problems. There's a lot of smart people in the world, but they're working on things like TikTok 2.0 or Snapchat, things that aren't really moving the needle. And so we thought, how can we build an institution that specifically trains people to solve important problems in the world? And we focus on knowledge, skills, mindsets, and networks to help you create the future and not just participate in it. So if we can go to the next slide. There is a quote that I really like, which is, the limit of global progress is the ambition of the most ambitious. Like if Elon didn't want to go into space, there would be very few companies, and he actually pioneered that. Now you see Jeff Bezos with Blue Origin, or Virgin Galactic and Blue Origin also trying to get into space. But if someone is not trying to push the limit, that is almost the limit of global progress. And so what we want to do in TKS is help foster that ambition. If you're curious and if you're driven and you're ambitious, this is going to be the place where we can take that to the next level. And that's what a lot of students at TKS are doing. It's not thinking about how I can be 10% better or how can I help solve a problem 10%, but rather 10x, 10 times better, right? 1,000% better. So that's really what TKS is about, and that's the essence of TKS. And as a result of the work that they're doing, our students are getting recognized. This is definitely not the reason to join TKS, but it's just to show you the value of the training. So students are speaking at some of the top conferences around the world in front of 30,000 people, 50,000 people. Isabella will tell you a story about how she got a standing ovation at an internal Microsoft conference in front of like 30,000 people and got to meet Satya Nadella, who's the CEO of Microsoft. So this isn't to say that if you join TKS, you're going to get these speaking opportunities. That's possible if you put in the work, but it just goes to show that the impact and the effort that what you work on here is getting recognized globally. Yeah, and we talked about they're getting recognized in all those articles, Forbes, Fast Companies, and all that stuff. And again, this is not a reason to join TKS, but it's also just to show you that if you do go through a program like this, it should not take away from school. Yes, you're going to have to balance, and if this is a priority, like you get out of it what you put into it. But our students are getting into some of the top universities, right? So you don't have to sacrifice on this. For any of you guys who have questions around time commitment, John Hopkins, UPenn, Berkeley, Stanford, Oxford. So Izzy, she'll talk about her journey and how she got accepted there. The list goes on. But yeah, the main message of this slide is you don't have to sacrifice, and you can still get into some of these institutions that you're really excited about. But TKS is not about getting you into the best universities. It's about training you to be the best version of yourself, have amazing experiences, build an awesome portfolio, just be an interesting person, And yeah, you will get recognized as a result of these things. And the last thing that I wanted to share is our directors are the people who are supporting you throughout this journey. You essentially get 24/7 access to your mentors, and who are your directors, who are guiding you throughout this process. And these are not teachers. They are former founders, so people who have started companies. They've worked at top tech companies like SpaceX and Apple and Microsoft, influential roles at startups. They've worked in venture capital, consulting, and they are full-time dedicated to this to help superpower you. These are not part-time mentors. They are not just people who chime in here and there. You will always have access to these mentors, and they'll be able to help you push your thinking, raise your standards, connect you with people, offer guidance. And so this really is an all-star group of people to help guide you and figure out how you can accelerate your trajectory. So how does TKS work? Am I going into that, or Izzy, are you going into that?
When it's a picture of me.
When it's a picture of you. Okay, so how does TKS work? Let me talk about that very quickly. It's a 10-month program, starts in September and ends in June. So we have 3 levels of TKS. We have Foundations, which is for 11 to 13-year-olds, but the ones that most people on here will be interested in is Innovate and Activate. So these are for 13 to 17-year-olds. The first year program is Innovate. The second year program is Activate. Innovate is all about learning about these emerging technologies, getting a better understanding of yourself, what actually drives you, meeting really interesting people and developing these awesome friendships from around the world, and really working on projects. So diving deep into AI, diving deep into quantum, whenever and whatever you're excited about. So there's no grades at TKS. You move at your own pace. It's very personalized for you. So not only will you be building projects in the first year, but you're also going to be working on something called challenges, where we work with companies on some of their top business priorities. I mentioned earlier on in the call, we're working with the United Nations and X Prize this time. We've done challenges with Microsoft, with Nestle, with Walmart, like literally some of the top companies on some of their biggest business priorities. And then year 2 is focused on solving problems in the world. Let's get a really deep understanding of a lot of these problems that are affecting our civilization and why haven't they been solved yet, and then figure out how to activate solutions to these. And then after TKS, you join the alumni community, where we're piloting a venture fund to invest in some students who want to start companies, to work with other companies through consulting, and then just get jobs. And so those are some of the things that we're actively building out right now, but the main meat is the program. And why you should join is if you want to just become a better version of yourself, you want to become more interesting, and you want to accelerate your trajectory. I'm going to hand it off to Izzy.
Awesome. Hi everyone. I'm Izzy. I am 17 right now. Nadeem briefly gave me an introduction, but I went through 2 years of TKS, so the Innovate program and the Activate program. And TKS was really the amplifying force in my life for me to identify the things that I'm really passionate about and the things I want to dedicate my life towards. So right now I'm running a project where we're trying to end maternal mortality by distributing life-saving drugs to hard to reach and rural communities. Right now we're working on a pilot with the Ministry of Health and a local nonprofit in a northern state of Nigeria. So I'm very passionate about women's health, but TKS was really a journey for me to go through and understand what was I really excited about, what technologies, what sciences, what are the skills that I really want to work on. And throughout the program, I explored so many things. We had all sorts of sessions around technologies like blockchain and quantum computing. I got interested in artificial intelligence and a technology called cellular agriculture. And this is a picture of me at Web Summit, which is the world's largest tech conference in Portugal. And this was about a year and a bit into my TKS experience. And it was an opportunity I would have never gotten otherwise. And those are my friends and I, we were talking about the future of climate change and how we can attack it from 3 different angles, from food technology, from batteries, and from new types of energy storage and energy production. So all of these things I would have never done if not for the exposure of TKS. So I'm going to walk you through my story a bit and also my perspective of what the program has done. And I know Nadeem touched on this earlier, but I have not sacrificed on my education in my school. I got accepted into Oxford for the Human Sciences program, which is a whole journey in and of itself. I also yesterday got a full ride scholarship to the States for at UNC Chapel Hill. So I'm getting a lot of really great opportunities. And again, a lot of them are because of the seeds that TKS planted in my life and in my journey and in my exploration. So going into the types of session, this is sort of like what I like to call the Costco of figuring out what you're passionate about. TKS is a Costco. It's where you can sample, it's where you can try things. So I learned about different technologies and sciences. I learned what I liked more, what I didn't like more, but what was still interesting. We do challenges, like Nazim briefly mentioned, where we work on a real business problem with a company and we work in teams to try to solve it. So you learn about different companies in different domains. So I learned about Walmart and the retail industry. I learned about Wealthsimple and the financial tech industry and so forth. But you also learn how to work in teams and how to collaborate and how to build things together. And then also hackathons, which are sort of like these mini challenges you can also do in teams. So again, like a big part of TKS is doing teamwork and learning how to collaborate, because that's what happens in the real world. It's what happens at companies. It's what happens if you want to start your own company. But I find in school, I found teamwork dreadful. I still generally do, because it's like, oh, I always do all the work, or it's not that exciting. But the hackathons and the challenges that we do at TKS are great ways to form friendships, but also great ways to actually simulate these important skills for real environments. And then the part I didn't really expect going into TKS, but what ended up being my favorite part of the program is the personal growth. It's the community that you're in that's always striving to become better, from their mindsets to their habits. And I just found it so refreshing. So that's definitely a huge part of the experience that I'll really cherish. In terms of skills, you learn lots. Like you learn about presentations and decks, just graphic design, thinking about colors. And it's so important, because if you had an idea, if you had the best project in the entire world, but you didn't know how to sell it, or you didn't know how to raise money for it, then it doesn't actually matter what the product is. So these skills are very important, and I've used them in so many scenarios outside of TKS. You develop really unique knowledge. I can't even tell you the amount of times I've used just random pieces of information, if it was like a gene editing fun fact or literally anything. Actually, in my Oxford interview, which you have to do to get in, I think there was a question that had to do with one of our emerging technology sessions, and I just threw in a whole bunch of information that I would have never learned in school, but because we had those discussions, it really helped me in the interview, and we had a really interesting ethical discussion. In terms of the process and how students work on these interesting projects, like what I did, there's 3 steps to it. There's the explore phase, which is where you get access to learn about sort of like the high level of the technologies to see what you really fancy. And then you go into a focus, which is all about depth. So going beyond just AI, going into building projects, going into subdomains of AI, going into, maybe you want to focus on AI in healthcare and maybe AI in female healthcare, whatever it is, but you can really drill in on there. And then innovate is about pioneering something new, a new idea, combining technologies, becoming someone that is a very large, the word thought leader is on the slide, so a thought leader. This is another thing that you learn. It's called a one-pager, which is, I use one-pagers so often, especially for M, which is the project that I'm running. You have to summarize the way our distribution works, or we have to summarize the flow of our training program. So one-pagers, amazing skill, kind of builds on this idea of presentation and communication. Websites, I'm just going to skim through this, but you get to build a student portfolio. This is just a little snippet of mine. And I think what's awesome about the TKS program is you have access to the digital platform where you can centralize all your portfolio, from your videos to your articles. If you write newsletters, you can add that in there. So it's a really awesome resource to have. Mindsets. I love the mindsets. That's my favorite part of the program. Yes, you learn about technology. Yes, you learn about science. Yes, you get to nerd out and you get to talk about the future. But really, it's the personal growth that I find the most rewarding part. So you get lots and lots of guidance. There's a mindset of the week every week, which is always really helpful to set your intentions and have a great week and grow from that. Communication. I think this is sort of like this underarching theme that TKS has really helped with, because you can't collaborate without communication. You can't build the next insert whatever you want to build without working in a team or collaborating with people, whether it's a phone call with a lawyer or figuring out how to raise money. Communication is so central. So I've written 100 articles at this point. It's been 2 and a bit years, and I only started writing articles because of TKS. I've learned how to email. I learned how to use LinkedIn. Such invaluable tools now that I'm working on a project where I have to connect with people, whether it be those lawyers or people to raise money from, or people that can give really useful feedback. And then this is a fun example, an email I sent 2 years ago because I said I was 15. And he had started a multi-million-dollar company. And the response was pretty crazy. It was this part. Oh, went back. That he says no to everyone these days, said no to the last 100 or so people. But when I asked to have a phone call, he said yes because my blog was impressive, etc. So there's some really cool real world outcomes. Another one that Nadeem mentioned earlier is I got to meet Satya Nadella, who's the CEO of Microsoft. After speaking at Microsoft's one of its largest internal summits, I spoke in an arena in Las Vegas and I got a standing ovation. And I don't even know how I didn't cry on stage because that was just such a crazy feeling. So lots of really cool outcomes. I have friends that are sending emails, or they're talking to the godfathers of AI and biotech. So really, really useful skills. Challenges, I'm going to skip over this part because I know we mentioned it a bit, but this year TKS is working with the UN on gender equality, and I think it's specifically on digital inclusion and making sure that women have access to technology, which I think is such an important challenge, especially given that I'm working in a women's health project where we want to eventually enable the use of mobile technology for health data and to improve access to health data in rural communities to see how policies should be built. So super cool challenge. I'm really excited to see the outcome of this challenge. Online learning modules. This is like, I'm kind of just listing things and I'm only listing the surface level of what TKS is. There's so much you can do with the program. It's the Costco of all things. I don't know if you've ever been to Costco, but it's really easy to get lost in Costco, but it has so many valuable things. And these online learning modules are one of many. Weekly guidance, this kind of comes hand in hand with the mindsets, but you get guidance depending on different sessions that you're working on. So for example, one of my favorite sessions is the Harvard business case session. So this is taken from a very similar approach to the Harvard Business School. So if you were getting an MBA at Harvard and you work on a case revolving some sort of company. So we've done Starbucks, we've done Alibaba. And so the weekly guidance would center on how to prepare for that session. And these are playbooks, again, like full of resources. The entire platform has access to those. And speaking of resources, you have an amazing community that holds you accountable, and you do things called brain dates. This is a picture of my like brain date feed where you can see everyone that I've brain dated, but I've had so many amazing conversations. And one thing I like to say is out of my 10 closest friends, 6 are from TKS, 2 are from high school, and 2 are from my childhood. So you'll meet some really amazing people. And you can interact with them on the online community Slack. Slack is amazing. The This Is Cool channel is my personal favorite. It's great. And I think we'll end off the presentation here. Applications are open, but I will stick around to answer any other questions that we have.
Sweet. So what I just wanted to emphasize is that TKS is a holistic program. It's not like you just show up for 3 hours, but you have a lot of resources that you have access to. As you mentioned, that you have playbooks, you have the explore modules, you have a way to meet all of these exciting and interesting people who are in the program all over the world. You have ways to access mentors. And on top of that, you have your sessions. And on top of that, you have the process to learn, which is the focus process that if you are accepted into the program, we'll tell you a little bit more about, which we think is the best way for you guys to learn as much as you can in a short period of time. So I think, I'm obviously biased, it's super awesome. We have 800 people, active people in the program, and we just want to make sure that we can serve as many people as possible to help unlock their potential. So if you guys have any questions, we can get to answering them.
I'm just peeking at the YouTube. I know there's a couple of questions about balancing TKS in school, which is a classic question.
Classic.
Classic. I have done excellent in school, obviously the grades to get into some of these great institutions for post-secondary. So I definitely didn't do a lot of clubs in school because it's like, do I want to do the debate club that every person else is doing, or do I want to learn how to build technologies and solve global issues? Like, it's always the latter. And I've loved doing my own thing and starting my own project. So that's just the type of person that I am. But I have done a great job of balancing my grades and my education with TKS and everything it has to offer. And I think the part that really excites me about school is it's the foundational knowledge that helps you. All of a sudden you realize, oh, math does have a purpose. You can start to see how it weaves into AI, or you start to learn about chemistry and you're like, oh, I like all of this because it makes me understand these research papers more. So I kind of saw school as not this like holistic human development program, but a place where I can gain knowledge. And a TKS is a place where I can start to apply that knowledge. And with my time management, I was able to figure it out. I don't use a lot of social media. I don't watch a lot of Netflix. If anything, I just watch documentaries. I love reading books. It's my favorite pastime. I make time to read in the morning, in the evening. And it's just something that makes me realize that it's okay to go slow a bit, and it's okay to be a little bit more thoughtful of your time. Whereas I feel like people just say yes to everything and they try to cram it in. But if you're a little bit more intentional, you time block, you can make time for the things that you love, like reading. So
Yeah,
I would
so
basically say, oh, go ahead.
I was going to say, here's the thing, that in the last 3 to 4 years, we've had over 1,000 students go through this program. Trust me, you can figure it out. Time management and prioritization is a skill. We're going to help you build this skill. If you have a lot going on, it'll probably be a little bit more difficult for you to adjust, but it will happen as long as you make active efforts to do it. But just so you know, when you join the program, yes, you might feel that way initially, but after 2 or 3 months in the program, as long as you're putting in the effort, you will figure out, and we will help you figure out how to prioritize. Next question.
Are you getting the question or am I getting the question?
I can't see any of the questions, Izzy, so if you can see.
Okay. Is there something like a syllabus for the upcoming year so there will, once you get accepted into the program, I believe you have access to sort of a schedule. But what's cool about TKS is if there's something cool happening in the world, the curriculum will adjust. Like if we go to Mars, there will be a Mars session. Or if there's like a really cool advancement in gene editing, generally that will be adjusted. And then the challenges stay surprises, but there's a certain chunk of time left for challenges.
Yeah. So the cool thing about TKS that Izzy mentioned is that we're not like school where we have a curriculum and we keep doing the same sessions over and over again. We build our sessions 2 weeks in advance. So we have a whole team that Roberta says she can actually pull up the weekly session. So yeah, if you want to do that, Roberta, that would be great. But yeah, we build the sessions in real time for you. So whatever you're getting is the most up-to-date information. And then yes, the challenges that we work with, it's not like we've scheduled this 2 years in advance. We always want to work with companies that are working on some interesting things that are the most relevant for you. So when Roberta finds it, she'll pull up the screen of what the sessions look like. But there's typically technology sessions, which are like AI, quantum, nanotech, gene editing, brain-computer interfaces. There's challenge sessions, there's hackathons, and life and success and all this other stuff. So if you see here, this is the program schedule. So this, yeah, boom. Look at all this fun stuff. So there you go, for those of you who are interested.
Perfect.
Yeah, Izzy?
I'm going to pop to the next question, which is it possible that everyone can achieve this kind of success in TKS? And I think when you look at the internal success, which I think is the thing that matters the most, sort of setting yourself up for a meaningful life. It doesn't have to be that you don't have, like, speaking on stages, I don't think is a great measurement of success. I think, do you have mental frameworks that will help you lead your life and identify problems that you really want to solve, or identify ways that you want to spend your time to make the world better? I think that to me is success. And yes, everyone can get that, because it's a program that I think builds a lot of self-awareness into people, because you're trying so many things. You're meeting so many people. There's access to exclusive guest speakers, and you have this community of people that are very committed to their growth, which I don't necessarily see a lot in school. Generally in school, the people around me, their greatest ambitions are their grades. Whereas in TKS, it's almost like their greatest ambitions are discovering what those important things they want to do in life, or how they want to spend their time. And I find that such a really empowering community to be around. So what I'd say is, yes, everyone can achieve those mindset shifts and those friendships and relationships. And I think those are ultimately the things that matter in terms of success.
Yeah, the analogy that I would use is, imagine TKS as being the best gym membership for superpowering your potential. So say you get the gym membership and you have access to all the equipment, you have access to the personal trainer, you have access to the classes, you have access to the nutrition plan, all that stuff. But if you don't show up to the gym, and if you don't put in the work, you're not going to get fit. You're not going to see the results. And by the way, there are some people who are naturally fit and ripped and jacked, and they might look very different because they're just naturally that way. But if someone does come into the gym like obese, or say they want to lose weight, whatever the case it is, it is about your progress. Yes, you will put in the work, and it's science. If you put in the work, you'll get results. And so some people will see different results, but what I care about is your progress, your development, right? Are you growing? And that's how we measure your success at TKS, is not against an objective bar, but how much you feel like you've grown in a short period of time.
Nadeem, I'm just going to do a quick rapid fire because there's some like elementary questions. So the program, there's sessions weekly. In terms of prep for the sessions, it's about like 1 to 2 hours. Sometimes there's no prep, but there's no like time commitment. But you put in what you put in is what you get out. There are no prerequisites to the program. So you come in, you might have to catch up. You might have to brush up on basic biology. You might need to take math courses. I find the STEM courses I took in high school were really, really helpful. I did join TKS when I was in grade 10, so sophomore year, and I did it in junior year. You don't have to do both years of TKS though. And some people actually do the first year twice. And that's totally fine. If you want to continue learning about technologies and you don't really want to go into problem solving or looking at more non-technical issues, then do the first year program. I have tons of friends that have done the first year program twice. Some people have done the second year program twice. So there's really no like graduation scheme. If you're 18, I think you can still try applying. Nadeem, do you want to correct me there?
If you're 18, you can apply to the virtual program, but if you're applying to the city-specific program, it is between 13 to 17.
Great. I do like books too, Blade. So that's a good comment. In terms of how do you know if TKS is right for you? I think if you're someone that wants to explore and doesn't have like a set path, but they know they want a meaningful life, like the only thing I was really sure of is I just didn't want to be in a 9-to-5 job when I was older, but I was really interested in a lot of different things. Like when I was 14, I made this like 24-page document outlining how I really cared about health and like how I wanted to study it and what interested me. And I found that recently, and I was like, wow, I had this like detailed plan, and now that plan looks really different. But I was someone that wanted a bit more. So I think if you're of that mindset where you want to explore, you want to learn more, you want to build some really meaningful friendships, and you want to see how you can live a life that's more than just a 9-to-5 job, I think TKS is a great environment for you.
Yeah, so here's the criteria, and I'll give you the answer for the application process. Are you curious? Meaning you don't, ever since you were 9 years old, you have wanted to be a doctor, and that's all you've ever wanted to be, right? That's not curiosity. You don't need TKS for that. There's a clear path. You want to be an investment banker, that's all you ever wanted to be. So that's who's not a good fit. But if you're curious, you'd be a great fit. If you're driven, so you have some internal drive or motivation to do something, and you have a strong work ethic. You're willing to put in the work. You're not just relying on your natural talents. Like, yeah, you could just be a smart person, get good grades in school, but I care about growing you to be a way better version of yourself. And so you got to put in the work to capitalize on your potential. If you have those 3 characteristics, you'll be a great fit. We don't care about grades. We don't care about age. We don't care about school. It really just is about your personal characteristics.
Perfect. I'm going to answer some more rapid fire ones. So in the virtual program, I believe it's over 150 students. And in the Boston program, correct me if I'm wrong, about 50 students. I think next year it's 80. And we do not learn all digits of pi. That is not in the curriculum yet. Also, that's an infinite number. Networking is important. That's true. There's a couple other questions I'm just scrolling through. How do you get accepted? Nadeem kind of outlined that. Just be yourself. If you really, really want to grow, you show that you're interested in the program, your acceptance rates are also much higher. There are a few steps to the application process, but I would just say try your best. In terms of coping with assignments and meetings, it's kind of up to your own standards. Like in grade 10, I was taking more than, I think half of my school year was grade 11 courses. So I was always doing a year up. I was always trying to take the hardest classes, just because that's the type of person, those are the classes I enjoy, that was the stuff I liked, and I was able to keep really great grades. I earned distinction awards all throughout high school, so it wasn't very trivial for me. I'm not, like, I don't think I'm a super genius. I'm very focused on school. I know what I care about, and I set time for that. And there was a question about if people have done sports and clubs. Yes, oh my God, so many people have excelled in both things. Like TKS kind of becomes more of a lifestyle. It's like me asking, oh, do you brush your teeth in the morning? It's like, yeah, I brush my teeth in the morning. But there's so many little things that TKS introduced me to, but I wouldn't really consider it's an investment to the program. For example, podcast listening, I got really into after joining TKS, and that was something that at first kind of became part of the program. It became something I started doing, and now it's just part of my everyday life.
So guys, one of the things that I wanted to emphasize is that there's no homework at TKS. Like, you don't have to do anything, but we want people who have some sort of internal drive. So some people will put like 8 hours a week into TKS and say they have exams, like maybe like use your own judgment. But then there are some people who are like, man, I want to use this gym to the best of the ability, work out twice a day, and they spend more time. So they can do that. But if you're looking to do the minimum requirement to get the maximum output, again, that's probably not the right fit for TKS. So I wouldn't worry about mitigating your risk. I would worry about, or I'd be interested in optimizing your success by putting in the work.
All right. So people
So
are
is he
memorizing
saying Roberta's?
digits of
Yeah.
pi. Oh, do you have to wrap up? Okay. Let me,
Yeah.
there's
So
a few. Okay, go ahead.
I was going to
I
say
think
we
it's
should just go
lagging.
through a couple of them. We should go through a couple of the most important questions and then we'll wrap up.
Okay, great. Long story short, though, there's a couple questions. If you're 14, if you're 17, you can apply. There is the virtual program. There's also an in-person program. A lot of stuff will be answered on the website as well. So I don't know if we want to link that below. Is there any other? Is virtual better than in-person or vice versa? There's definitely, they're both great programs. I've only done the in-person program until COVID hit. I did the virtual. There's a lot of in-person that I love, like the friendships you get to build. It's a little bit different. Any other questions, Nadeem?
No, one thing that I would say about the in-person versus virtual experience is the reason why we're doing virtual is to support kids anywhere all around the world who doesn't have access to the in-person TKS session. So the benefit of that is you're going to be in cohorts with people from around the world. But there is something to the in-person experience. So if you are in a city where you are able to do it in person, we're optimistic that by September we'll be able to at least hold in-person sessions. And if not, we have a whole contingency plan around that. So I wouldn't worry too much about it. And then the last thing is financial aid. So yes, there is a tuition to TKS, but if you can't afford it and you're the right fit, we're going to try our best to make sure that you can participate in the program. Money and financial barriers should not play a big role in you not applying. Again, it's almost like, say the next Elon couldn't afford $1,000 to get into the program. That's almost silly to me, right? So the team is working really hard to make sure that we can provide as much financial aid as possible. So please don't let that be a deterrent from applying to TKS.
And just one last note, I know there's a couple questions of like how much time. What I'll say is there's no formula. And if you're looking for a formula answer, like a spreadsheet you can fill in to get the results, you're not going to find it because everyone's path is different. Everyone's journey is different. When I did the program, there was not 800 students in it. There was it was a smaller cohort. So the growth I experienced was less. There was less, or not less, but different because there was no historical data on what I was trying to do. Whereas now students that enter the program have a lot of that historical data and they have to sort of have different creativity. So I don't think there's a great answer for you in terms of how much time people put into their projects. But I would say generally the more time you put in, the more results you get out. The more time you spend being different than school or doing things that are more unconventional, the more results you'll see there.
Also, we have sweet swag, so top reason to join. All right, guys,
Yep.
So that is everything. If you have any more questions, check out the YouTube, check out the website, Instagram. There is a website page. There's a link where you can schedule time to talk to TKS participants. You can see what they've worked on. You can see their projects. Roberta, I don't know if you want to pull that screen up or paste in the chat the website link to schedule a conversation with a TKS student. But I think that's the best way to learn about the program. And there's tons of people there that you can talk to. So if you are interested, I would just figure out a time to talk to the students about their experience. All right, applications open. Hope you guys apply if you're interested. Hope you had fun. See ya.